I created this application to demonstrate how computer vision can be very transformative in the area of environmental monitoring. This is a completely free application, so feel free to use it. There's no sign up and there's nothing really to install. As you can see, I have a number of auger plates that I have used in my training set, and I'll just show you some of the features that are associated with them. And of course, yes, there's bacterial colonies, but there's other components like Sharpie. You can see here there's some tape. If we zoom in, you can actually see some of the other features that are associated with the auger plate. This one has a strange sort of lattice structure in the background. Some of them have this manufacturer's component where it says lock versus unlock. And it's possible that we're looking at the other side of the plate, which is why they don't appear on all the sides of the plate. But you can see very clearly here that each one of these plates has small features that could potentially throw off any type of imaging that occurs. And they're all approximately the same because again, this is just my training set. So taking this training set and I've trained a model and we'll see what the results look like. In order to use the model, you simply just click on the word browse. And here I have just some examples that I've downloaded. And I'm going to just drop all of these in at the same time. So get an idea of what it's like to look at all of them. So here we have all of the different plates. They're listed here by the file name. And you can see one of the things that it does differently is it has classified these images. Uh, and it's not only looking for bacteria, but it also has some other classifications. So this is a Sharpie, right? This is called a gate. It's just a little, center bubble that occurs on some of these plates, but that is not a bacterial colony. You can see the word unlock and lock here. You can see that it's counting the number of bacteria in addition to some of these other classification components. And then you can see here, it's done some edge detection. It's looked at and it's seen that's tape. So it's classified that as tape. So we're able to detect some of these other features, which are not important to a bacterial colony count itself, but which could distort the image. The little number you see on the right, this 0.89, this is the probability that it knows what it's seeing. So to that, probability 0.89, or 89% probability, that is in fact what the computer vision is looking at. So it takes all this data, and in this case, it dumps it all into this spreadsheet, which is convenient. And since all of these have a unique timestamp, all of these records are unique, and you can just look over and see how many colonies were counted from each one. That only took a few seconds, but that doesn't explain why computer vision is very different from traditional uh, imaging techniques. Let me show you how dynamic it can actually be. And I'm going to use this example, which is just stock image. So I just went to Google and I just did a search for, you know, bacterial colony on agar plate, and this is something that came up. So I took this image, right clicked and saved it to my desktop and then moved it into a folder. You can do the same thing with any other image that is, on agar plate. And then you just find that image, and here's my stock image. And then I'm going to drop that stock image in here. So it's already evaluated the stock image. And if you go to the bottom here, you can see it's colony counted all of the colonies that it can see, which were available on that stock image. Well, then it's put that information into the spreadsheet. So you can open up this particular spreadsheet here, and you can see what that looks like. Colonies, in this case, 45 from that stock image. You can download this spreadsheet. There's a download button right here if you wish, and you can run other metrics on it, trend analysis, for example. But the real power behind computer vision is the fact that this plate and this plate are both agar plates, and that these are bacterial colonies. So whereas you may have to have a lot more control with imaging techniques in terms of the lighting and where the position of it is and the distance from the camera, the auger, there's a little bit more flexibility in computer vision because in many ways it sees similar to the way human beings see, and then it classifies information and reports that information back to you. So please feel free to try this application. It's on. I'm going to put the description in the link, and please let me know your comments.